All right, welcome everyone for a Wednesday lesson here. Today we are simplifying radical expressions. It would help if I plug my little pen in. Here we go. All right, radical expressions. Radicals are those little square root things. We've done this a little bit before with square roots, okay? And that's usually given when we don't have a little number here. Okay, if there's nothing there, it's a 2, it's a square root, okay? And what that means is if we break apart 25 into 5 times 5 square roots, we're looking for 2 of a kind, okay? So what two numbers multiplied together equal 25? It's just going to be 5. It's just going to be one of those because we're looking for 2 numbers that multiply together, okay? When we look at cube roots with a 3 here, this is called our index, okay? So cube roots, we're looking for what number multiplied by itself 3 times equals 27. So when we break apart 27 into 3 times 3 times 3, and we do that again, remember, using our prime factor tree, 9 and 3, 3 and 3. So we're just rewriting this as prime factors, all right? When we're taking cube roots, and don't forget that little 3 there because that's important. That shows us how many of a kind we're looking for. If we have 3 3s, then one of them gets to come outside. So the cube root of 27 is just 3, okay? We can also find 4th roots when we have a little 4 there, 5th roots, 6th roots, nth roots, okay? In general, just there's an n there, that's our index. That's how many of the same factor need to be taken, okay? So let's keep that in mind. We've done that a little bit before, but it's going to get a little crazier today. All right, perfect roots. So these are where everything is coming outside of the radical. Okay, again, this is a cube root. My index is 3, so I'm looking for groups of 3 of a kind. Keep that in mind. All right, first thing with 27, again, we want to break this down into prime factors so that we can find those groups of 3. So 27 is 9 and 3. 9 is 3 and 3. So I can rewrite 27 as 3 times 3 times 3. And I can rewrite x to the 6th as x times x times x times x times x times x. All right, remember, I'm looking for groups of 3 of a kind. If I have a group of 3 of a kind, one of them gets to come outside, all right? Because once you've removed it from inside that radical, you've taken the cube root of it, okay? So the cube root of 3 3s is just 1. Now let's find groups of 3x's. Here's a group of 3x's, so one of them comes outside. Here's a group of 3x's, so one of them comes outside. And you can see everything gets to come outside of that radical, okay? So we can just rewrite our answer as 3x squared, okay? All right, again, perfect roots because everything came outside of the radical. All right, let's try a couple here. We have a 4th root here of 81 times y to the 12th. So again, we're looking for groups of 4. How do we find them? Let's break apart that 81. 81 is 9 and 9. 9 is 3 and 3. 9 is 3 and 3. So I can really rewrite 81 as, let me give me some room here. All right. I can rewrite 81 as 3 times 3 times 3 times 3. Okay. I can rewrite y to the 12th as y times y. 12 y's. Okay, so we're looking for groups of 4 of a kind. All right, when you write this root, this radical, don't forget that index ever, okay? Because that tells us how many we're looking for. I'm looking for 3 3s. One of them gets to come outside that radical. I'm looking for groups of 4 y's, okay? There's a group of 4, so one gets to come out. Here's a group of 4, so one of them gets to come out. And here's a group of 4, so one of them comes out. So my answer is just 3y to the 3rd. Okay. Again, everything has a group of 4, and you might notice that that y to the 12th, that's a multiple of 4, so everything's going to get to come outside there. All right. Oh, 5th root. Getting crazy here. All right. Again, when you write that radical, don't forget that 5. That tells us what root that is. It tells us how many we're looking for. When we break apart 32, 32 is 16 and 2 or 8 and 4. No matter what numbers you use, you'll always get the same prime factors. So 8 is 4 and 2, 4 is 2 and 2, there's a 2, and then this 4 is also 2 and 2. All right, so 32 can really be written as 2 times 2 times 2 times 2 times 2. X to the 10th, we can write those out, x times, and y to the 5th. But here's the thing. Let's start to kind of see this pattern. All right, groups of 5 now. All right, groups of 5. I have 1, 2 here. Now, how many groups of 5 do I have if I have x to the 10th? Okay, let's not write them all out again. That took me hours on the last problem. X to the 10th, I have 2 groups of 2. So I pull out 1x for each of those, or I can just write that as x squared. X squared, and then this one's easy here. How many groups of 5 do I have if I have y to the 5th? Just 1. There we go. Nice and easy. All right, non-perfect roots. Dun, dun, dun. These are ones that stuff gets left inside, okay? They don't get to come outside and play. So we have a square root because there's nothing there. So we can add a 2 if we want, just to make sure we know what we're looking for. Let's break apart 27. We know that's 9 and 3, and then 3 and 3. So I can rewrite 27 as 3 times 3 times 3, and I can rewrite x as x to the third as x times x times x, okay? Everything inside the radical. Now, when we look for groups of a 2, you have to have a group of 2 to come outside. So a 3 gets to come outside, an x gets to come outside, but hey, look, there's some stuff that didn't get, wasn't part of a buddy system, right? They don't get to come outside and play. So I still have a 3 inside, and I still have an x inside. Again, we don't have to write that 2 because when it's no index there, we know it's a square root, but you can if you want. It's a good habit. All right, so again, that's not a non-perfect root because we have some stuff in the radical still. All right, let's end on a couple good ones. We have the 4th root here, 96. Let's break that apart. I believe that's 16 and 6. If you're not sure, again, if it's even, you can always break it into 2 times whatever, okay? But this ends in a 6, so I know it's divisible by 6. 16 is going to be 8 and 2. 8 is 4 and 2. 4 is 2 and 2. All right, so I'm going to bring down these 2's also. It kind of helps me. And then that 6 is 2 times 3. So there's my prime factors. I can rewrite this as the 4th root. Again, don't forget that index of 2 times 2 times 2 times 2 times 2 times 3. 2, 3, 4, 5. Yeah, 5 2's. All right, x to the 10th, y to the 5th. All right, we're looking for groups of 4. There's a group of 4, so I get to bring a 2 outside. And I usually kind of leave room and I write the radical still so I can write what's left inside of there. Okay, x to the 10th, how many groups of 4 are there if I have 10 x's? I can pull out 2 groups, okay? X times x is x squared. Okay, if I pull out 2 groups of 4, I've pulled out 8 from that 10. That still means that I have 2 left inside, okay? Also, I forgot the 2 and the 3 that weren't part of that group. Those are stuck inside also, so let's not forget that, okay? All right, now looking at our y's, I have y to the 5th. I'm looking for groups of 4, so I can pull out just one group of 4, and if I do that, I'm left with 1 y left inside. Let's kind of clean this up a little bit, make it all one color. I have 2x squared y times the 4th root of 2 times 3 is 6, x squared y. All right, pretty messy, but these are kind of fun because you break them into those prime factors. You pull out groups of 2, 3, 4, 5 of a kind. Some stuff doesn't get to come outside. Not too bad. All right, let's try one more real quick. We're looking for groups of 2 of a kind from this 18, 9 and 2, 3 and 3. So square root of 3 times 3 times 2 times x to the 10th. What gets to come outside? There's a 3 outside, and there's a 2 inside. And then in x to the 10th, I'm looking for groups of 2. I can bring out 5 groups of 2, and if I do that, I've brought out all 10 of them outside. So those are all coming outside. All right, let me make that radical a little smaller there so we don't get crazy. There we go. Okay. Let me clarify here. Just, you see that 5, it kind of looks like an index. So I'm just going to kind of separate that or put a square there just so we know. Okay. All right, that's it. A couple problems for your self to try. If you have questions, come to my office hours 9:30 to 11:30 in the Google Meet. If not, I will see you on Thursday or Friday. Happy Wednesday, everyone.